Hi everyone, welcome to my channel. This is Leo, and let's do some more Leetcode problems today. Today's problem is called diagonal traverse. We were given an n by n matrix mat, and we're asked to return an array of the elements and in a diagonal order. So basically we traverse from here and to here, here, and then go up again, down again, and then go up until we reach the bottom right corner, okay? So this is like a matrix traverse, but it's totally different. Because first we need to take care of the direction, whether it's going up or down. And then what if we hit the boundaries? What will happen? Okay, so that's something we need to take care of. So first, I think it's good to know that we have a Boolean to see whether it's going up or not. So originally it was set to true, and we will have a coordinate, initial coordinate. So this R and C signifies the head of each iteration, okay? And also we will take care of the boundary issue, okay? So boundary. All right, let's take a look. So let's say we have a result array, and it will record the current cell, then go to the next cell, right? And next R, next C equals 2. That solely depends on whether we're going up or down, okay? So if we're going up, the next row will be row plus, row minus 1, okay? And if we're not going up, it will row plus 1. Next, also, if it's going up, the column will increment. And if it's not, it will decrement. Since if we go down, the column should go to the left, okay? Okay, and here is the boundary problem. If something is out of boundary, and there are several occasions where when we're going up, we can hit the up one, the right one, and if we go down, we can hit the left one and the down one, okay? So it depends on whether we're going up or else, okay? And every time when we hit the wall, we need to reset. We do some changes and then we reset the direction, okay? Here, like if we go down and hit this wall, we do some operations, we reset the head to this one, and we will reset the Boolean to make it go up, okay? So after that, we'll do this, okay? And else, if it's not out of boundary, we will just set our head to the next cell, okay? All right, now let's take a look at the up and down here. So if it's out of boundary, how do we set the R and C? So if we're going up and we hit the boundary, there are two different scenarios. If we hit here, we will go right. But if we hit here, we'll go down. So it depends on where you are column-wise. So whether column is n minus 1, okay? If it is n minus 1, the row will increment. If not, it will not move, okay? So we can add it to the row, okay? And also for the column, if it doesn't hit the last row, when we hit the wall, the up wall, the column will usually go increment, okay? And if not, when we're hitting the last wall, the column will stay the same. I think that should give us the right direction. And it also works here, okay? So R and C, let's see. If we're here, we're hitting this wall. It depends on where you are, row-wise. If we're here, the column stays the same and the row goes down. But if we hit here, the row stays the same and the column goes right, okay? So we can start with the column first. So if R is equal to n minus 1, in that case, our column will go right, okay? If not, it will stay the same. And now let's come to the row if less than n minus 1. If it hits the wall, the row will go down, and if not, if it's at the last row, it will stay the same, and only the column will change, okay? And I think that should be it. Let's now start to code it out, okay? First, let's do some sanity check. Or math0.length equals to 0. We'll return a new integer array with nothing in it. And now we can initialize the dimensions of the matrix, and we set the head, and we have the boolean initialized to true, and we will have a result array which is n by n large, and we will have a index for that, okay? So while r is less than m and the c is less than n, first thing we need to put our existing cell number into our final result, and then we find its neighbors equals to, it depends on whether it's going up, right? So, okay, maybe I can do this. Minus 1, 1, and next column equals to column 1, negative 1, okay? And next, we will decide whether it's out of boundary. So, out of boundary, next r is less than 0, or next r is equal to m, or next c is less than 0, or next c is equal to n, okay? So if either happens, if up, else, and we change up to not up, okay? If it's going up, so r will plus and equals to c equals to n minus 1. If it is, we have 1. If not, we have 0. Also works for this, and this we will see if it equals to, if the row hits the last row, okay? And row is less than n minus 1, 1, 0, okay? All right, else, if it's inbound, r will equal to next r, and c will next to next c, and return the result. This should give us the right answer. Let's see. Oh, okay, yeah. Probably I should add something like this. Okay. Yeah, that's it. And let's analyze the complexities. So for time complexity, since we're traversing all the elements here, we have mn, and for space complexity, if we don't calculate the output, it will just be pointers. So basically it's 01. All right, I think it passed. Thank you so much for watching. I'll see you in our next video.